minimum effort. You are a hiker preparing for an upcoming hike. You are given heights to the array of size, rows, and times columns, where heights row column represents the height of cell row column. You are situated on the top left cell 00, and you have to travel to the bottom right cell row -1 and column -1. So that's this row -1 is basically the last one here, and column -1 is the last one here. So that's it. You have to travel to the bottom right cell rows -1 and row column -1. You can move up, down, left, or right, and you wish to find a route that requires the minimum effort. Route's effort is the maximum absolute difference in heights between the two consecutive cells of the route. Return the minimum effort is required to travel from the top left cell to the bottom right cell. So this is our example one, a visualized image of our 2D array graph. Array and our output is 2, says that the out of 1 to this one we have a maximum absolute difference of 2 in consecutive cells. This is better than the route of 1, 2, 2, 3, 4. This one over here, where the maximum absolute difference is 3. And this is example 2, and it says heights, our heights to the array, and we have the output 1, the route of 1, 2, 3, 4. This one has a maximum absolute difference of 1 in consecutive cells, which is better than the route 1, 2, 5, 3, 5. So we solve this by so let's get down to the last example, example 3. Well, this one has one of each number. So to the array of it only has 1s and 2s in them, and we have the output 0 because it says that this route does not require any effort. So there's no difference, so there's no effort, so we get a 0. So now let's see. Let's make our dimensions problem involves the use of Dijkstra algorithm. So let's call them row and column, and equals to equals to oops, this is the easiest part. It's taking me time to think. Heights and length of heights 0 for the column. So our length heights column. Let's make directions for movements. Directions equals to let's make a list of, so that will be 0, 1, so 0 to negative 0, 1, 0, negative 1, 0. So now we have our directions for movements. So what's the next move? The next move is to let's make our list to start to the list to start correspond efforts to corresponding cells. So we're going to do this by let's call it effort and then equals to let's make float and then put inf inside and then multiply, so infinity value, so the highest possible value, and then multiply the column for every, which should be for array cell whatever, and range of row. So now let's make effort 0 0 equals to 0. Starting effort is 0. So now we're going to take what is called min heap will be min heap will be equals to, let's call it hold on, 0 0 0. So effort zeros for effort lower and cell starting out. Let's make our while loop and let's put min heap and then let's put current, let's call our first, let's call the current effort that we're in, current effort, and then R and C equals to, after we pop our min heap, so heap dot heap q dot heap pop and put min heap in it, and then so now let's see. So how will we be able to tell? Return the values of the value of the effort of the last cell if we are at it. So let's call if R is equals to the row is equals to the column. Nope. Row -1 and C is equals to col -1 return so the last one here is hold on, I need this. Return wait, why did I forget the last? So it's return heights but I'll get back to that. So it's what does it say? Bottom down again, bottom down. Wait, what? So it's basically current. What was I thinking? Current effort. So now we have that. So now let's make our direction movements. So form new cells for movement. For movements directions. So now let's make for DR, DC, and directions. Let's call let's call DR. No, new cell. So new row and new C equals to R plus DR and C plus DC. So now let's check. So this will be our new cell. So after we move this, add these up. So let's check if it's within boundaries. Let's check if it's within boundaries for us to later use that cell. So if it's within, if row is, so that will be less than or equals to so if within new, if new r is between 0 and less than row, the dimensions are here, and new, oops, 0 is the same format, 0 less than equals to oops, new C, let's take, and also less than C, we column. So if it's less than that, so let's now calculate the absolute value. So what are we gonna call? Let's call it new effort. New effort will be equals to for no, what was I think? The maximum of either the current cell effort inside LR or the absolute value of our height, whichever is higher. So height new R C R height a new R new C minus heights, the next one. So this one is the new one, this is next one. It doesn't matter which order because we're using absolute value anyways. So heights are C. So now let's make so if new effort is less than our current it's a new. If new effort is less than effort that you are, if the value of new effort is less than the new R's index, new R and new Z. Let's make a new C, a new effort. This. Let me copy this. Equals to new effort. So the new effort will be whichever this is. So we can push this later on to the heap. So which we're about to do, heap dot heap q dot heap dot push it into min heap, and let's put new effort and the next value, new effort, and then new and then new C, and that seems to be it. So now let's return. So let me scan quickly for any syntax errors. Oops, find one already. I mean two. Hopefully it goes on the first try. Let's see. Oops, almost never where it says argument must be a list. Media. Oops, another one here. Let's see if it works now. And it's been accepted. So our time and space complexities. Our time complexity is O of log at the end, log n. So we have to go through every array, and we're using the here function, so that's n of log n. So our space complexity is O of n. So that's it for this problem. Let's submit to see if it's going to pass all problems. And it's been able to pass all cases.